Hello everyone, it's Miss Lim again. In the first part of the moments video, we have covered that a moment is a turning effect of a force. That means a force causes something to turn. And we have also learned that moments equals to force times the perpendicular distance between the line of action of the force and the pivot. So we have learned how to calculate the moments, and that moments have got direction. So they are both clockwise and anti-clockwise direction. Okay, in this second part of the video, we will be covering about the principle of moments, okay, which is describing when is an object in equilibrium. That means the object doesn't turn. What conditions are there when the object doesn't turn, and how do we explain it in terms of moments? Okay, so over here you have a QR code. You may scan the following QR code. It will bring you into this simulation, which is called balancing act. In this simulation, there are three parts: intro, balance, lab, and game. In the intro section, you have a fire extinguisher and a rubbish bin. They have different mass, and then you can position them along different position on this wooden rod. And the main purpose is to try to balance this wooden rod. You can play around with it to see that how does the distance and the weight of the object changes, or how or what position do you need to position these two items in order for them to balance. There's quite a number of combination that will cause this wooden plank to be balanced. Okay, and then after that, if you have found out the relationship that causes these two objects to be balanced, you can move ahead to play with this balance lab. There will be more examples in this balance lab. There's many mystery items that you can try to find the mass of the mystery items. And then if you are ready for that, you can play the game as well. But in this video, we will not be going through this simulation. Okay, we will move on directly into the theory part. Okay, so in the theory part, the principle of moments, in short, we call it the POM. It states that when a body is in equilibrium, the sum of the clockwise moments about a pivot is equals to the sum of the anti-clockwise moments about the same pivot. Okay, so the words in bold are important. Okay, you need to know the meaning. And in exam, these words in bold must be present if they ask you to state the principle of moments. It's a definition question. So it states that when an object is in equilibrium, equilibrium means that it's balanced, it is not moving, it's stationary, okay, over there. So there are conditions for equilibrium other than clockwise equals to anti-clockwise moments. Okay, the resultant force acting on the object must also be zero so that the object doesn't move at all. It doesn't rotate, it doesn't move. In this case, this one is only for no rotation. So when will I have no rotation is when all the clockwise moments, okay, there may be more than one clockwise moments because there may be more than one force acting on the object. So all the clockwise moments about this pivot over here, orange pivot, must be equals to all the anti-clockwise moments about the same pivot. Okay, so when clockwise and anti-clockwise is balanced out, this object will not rotate at all. So what do I mean by that? Let's look at this. Okay, so I have a force W1 over here is exerted over a perpendicular distance D1 from the pivot. So over here, I have a moment, and this moment is the anti-clockwise moment. It causes this rod to rotate anti-clockwise. And then over here, I have another force. If I don't have any force, this rod will not be balanced because I will have a resultant anti-clockwise moments. The net moments is not zero. There will be a moment which is caused by this anti-clockwise moments. So in order for this rod to be balanced, I need to have one more force downwards over here. This force W2 downwards over here will create what we call the clockwise moments. Okay, so I just look at the individual force, W2 and the pivot. W2 will cause the rod to turn in this manner. So it is causing the clockwise moments. So this clockwise moments will be W2 times D2. And in order for this entire rod to be balanced, it's not W1 equals to W2. I do not need the two forces to be balanced, or neither do I need the two distance to be balanced. They can be placed at many different positions, and it can have many different weights, but this rod can still be balanced because okay, is governed by this principle of moments, which says that, so in this case, I only have one anticlockwise and one clockwise moment. So my anticlockwise moments will be force times distance, W1 times D1, must be equals to this clockwise moment, also only one, W2 times D2. Okay, so let's take a look at more difficult examples. So in this case over here, I have a rod with many different force. Okay, and this is my pivot in the center, and these are the individual distance, okay, of the forces. So the first question they ask you, what is the sum of the clockwise moment? So I have many different force. Okay, I need to identify which are the forces that will give me my clockwise moments. So I hope you should be able to identify that my clockwise moments is caused by this 10 newtons as well as this 5 newtons. Just take note that I have two forces that causes the clockwise moments. So the clockwise moments is consisting of two different clockwise moments. I have one clockwise moment caused by 10 newton and one clockwise moment caused by the 5 newtons. You cannot add them both up. I cannot have 10 newtons plus 5 newtons, then I have 15 newtons, and my total distance is 0.6 plus 0.4. I cannot do that. I need to count the individual moments. So for the clockwise moments, I have two of them. So the first one will be 10 newtons times the perpendicular distance is 0.6, 10 times 0.6, plus I have one more, which is 5 newtons over here, and the perpendicular distance, just take note, the perpendicular distance is not 0.4. The perpendicular distance is between the line of action of the force, so the force is over here, to my pivot. So it will be a total distance of 0.6 plus 0.4, which is 1 meter. So I have two moments over here, 10 times 0.6 and 5 times 1. Okay, so this will be my total clockwise moment, which will be 11 Newton meter. So then next, what is the sum of the anti-clockwise moment? So I move on over to this side. These two newtons and 8 newtons will cause the anti-clockwise moment. So again, by the same step, I will be consisting of two forces. I will have two moments, anti-clockwise moments. So the first one will be 2 times 0.5 plus another one, which is 8 times a total distance of 1 meter pivot. So it's 2 times 0.5 plus 8 times 1, I get 9 Newton meter. So in this case, you will see that the clockwise moments is not the same as the anti-clockwise moments. So what is the net moment? The net moment is not zero. Net moment is like the resultant moment. There will be a resultant moment because it's not balanced. Okay, so the resultant moment or the net moment will be 11 minus 9 is 2. And it's 2 Newton meter clockwise because the clockwise is more than the anti-clockwise. So next question, part D, will this beam be balanced? No, obviously no, because I have a net moment. Okay, they are not equal. My clockwise is not equals to my anti-clockwise. If my clockwise is equals to my anti-clockwise, I will have zero moments, zero resultant moments. Then I will be balanced. So in this case, the beam will not be balanced. And which direction will it turn? Because my net moment is clockwise, this whole beam will rotate clockwise. Okay, so the conditions for equilibrium, okay, means the object is stationary or not rotating about any point. Okay, there are two conditions. First one, the resultant moments must be zero. There must be no clockwise or no anti-clockwise moment overall acting on the object. The next one is the resultant force must also be zero. We know that if there is a resultant force from the chapter on dynamics, if there is a resultant force, then this object will move. This object will not be stationary. Okay, in order to be stationary, the resultant force acting on it must also be zero. So these are the two conditions for equilibrium. Okay, so next I go into some of the steps to solve moment questions, and you will realize that most of the time you can use these steps to solve, no matter how complicated the question is. So whenever the question asks to find a force or a distance, not asking you to find moments. If the question just asks you to find moments, you just use force times distance. Okay, but sometimes the question, you know that you see a pivot somewhere, you know that it must be linked to a moments question. So when it's linked to a moment question and they're not asking you to find the moments, they ask you to find the force or distance, you use the following steps. So step number one, you always identify where is the pivot first. After you identify the pivot, identify all the forces present. Okay, if I have 5 forces, I should have 5 moments in my calculation. If I have 3 forces, I should have 3 moments in my calculation. And for each of the force, you need to determine whether it's a clockwise moment or anti-clockwise moment. Best if you can label it on each of the forces so that you will be very clear in your calculation. Which one is clockwise? I just use the short form CM. And which one is anti-clockwise? I just use the short form ACM. Okay, after I've determined all the clockwise and anti-clockwise moments in my head, okay, you may not need to write this down because it will be very messy on the diagram. Okay, in your head, you must think of the perpendicular distance between each of the force and the pivot. Okay, this perpendicular distance is always the tricky one that students have issues in identifying where is the perpendicular distance. Okay, then after that, I apply the principle of moments, POM, which says that I need to write these 2 statements down, taking the moments about the pivot, or about P or about Q, which is the pivot point. The sum of the clockwise moments equals to the sum of the anti-clockwise moments. And then I have some students who ask me, can I write short form? Sum of CM equals to sum of ACM. In maybe practice questions, you may write that, but just take note that for exams, these 2 statements must be written and it must be written in full. You need to spell out clockwise movements, you need to spell out anti-clockwise movements because it's not recognizable in O-level for CM and ACM. So you need to spell it out. Okay, so there is no shortcut. So I personally prefer even when you are doing your homework sheet, it will be good if you can spell out so that it makes it a habit that every time when you come across this kind of question, you will write out the entire thing. So now let us apply all these 4 steps into calculation questions. Okay, I have a rod over here. This whole system is balanced in equilibrium. I want to calculate this unknown force over here. So I know it must be linked to moments because there is a pivot here. And I'm trying to find either a force or a distance. I need to know, I know I need to apply the 4 steps. So let's go on to apply the 4 steps. The first step, identify the pivot. So this one is very straightforward. The pivot is at this triangle over here. The second step, I need to see how many forces do I have in the question. All the forces are labeled very straightforward. I have 1 force, 2 force, 3 force. And then I need to label on them whether they are CM or ACM. So the first one, the force is step number 2, which is ACM, CM, CM, clockwise, clockwise, anti-clockwise. Okay, then I move on to my step 3, which is mentally, I need to think the perpendicular distance. So for this force, perpendicular distance is 0.8. For 6 Newton, the perpendicular distance is 0.6. And for 4 Newtons, the perpendicular distance is all the way to the pivot, so it's 1 meter. So this one you just think in your head. Okay, then after that, I move on to step number 4, apply the principal moments. I obviously need to write this statement. Before you need to think of anything, just write this statement. Taking moments about pivot, sum of clockwise moments equals the sum of anti-clockwise moments. Okay, so after you write this statement, let's put in the numbers. So you should have labeled on your diagram. So I have clockwise moments is caused by 6 Newtons and 4 Newtons, 2 of them. So I need to have 2 moments. So the first moments will be 6 times 0.6 plus 4 times 1 meter. Okay, then equals to anti-clockwise. Over here, I only have 1 anti-clockwise, so only 1 moment is F times 0.8. So over here equals to F times 0.8. So after that, I have a whole equation with only 1 unknown. I just solve for my F. My F will be 9.5 Newton. Okay, it's Newton because it's a force. Okay, next. Okay, the next question is a little bit different. Okay, again, I know it must be linked to moment. Determine the force R exerted. Okay, but over here, in your head, you should be able to think that, hey, this R doesn't have any moments because this R is exactly at the pivot. So I have a force, but I don't have any perpendicular distance to the pivot. So I'm not going to use the traditional method of sum of clockwise equals to sum of anti-clockwise, the principal moments. I'm not going to apply that. Okay, I need to apply the other conditions for equilibrium. Okay, the conditions for equilibrium is other than clockwise equals to anti-clockwise, so I have 0 moments. The other condition is the resultant force acting on this must be 0. So for such questions where the force is exactly at the pivot, how do I determine it? I always use all the downwards force must be equals to all the upwards force. The forces are balanced up and down. So this rod will not move up. This rod will not move down. This rod will remain stationary at this pivot. So we have this. The net force must be 0. So what does it mean? The forces are in upwards and downwards direction. So upwards force must be equals to the downwards force. So my upwards force is R over here, and my downwards force is actually 9.5 Newton plus 6 Newtons plus 4 Newtons over here. So it will be in a total 19.5. All my downwards force is 19.5. My upwards force over here must also be 19.5 Newtons to have 0 resultant force. These only apply for force exerted at the pivot because there will be no moments here. You can't calculate principal moments. Okay, let's take a look at a little bit more complicated examples. Determine the magnitude and direction of the force F at the 95 cm mark over here of the ruler that is needed to balance this entire setup. So again, I know that I must be using principal moments because it's a pivot. There's a pivot over here and I'm trying to find a force. So in this case, first step, I identify my pivot, which is this triangle over here at the 20 cm mark. Second step, I look at the number of force. I have 1 force, 2 force, 3 force, 4 force, 5 force. 5 forces, and I need to label them whether they are clockwise or anti-clockwise. So let's go one by one. 20 Newton is this side, so it will be anti-clockwise. And then 50 Newtons is this side, okay, but it's going up, so it's also anti-clockwise. This is clockwise, this is anti-clockwise. Okay, so you take a look. I don't know F. F, I do not know the direction. I'm supposed to state the direction, but you take a look at the question. I have anti-clockwise, anti-clockwise, anti-clockwise. I only have one clockwise, and this clockwise, the force is so small, the distance is also so small. Okay, 20 Newtons, and the distance is only 50 minus 20, 30. It's very small. So most likely this force, you should be able to think in your head, this force must be a clockwise. Otherwise, I have too many ACM, and the CM will not be balanced to the ACM. So this force must be clockwise. So in order to be clockwise, this force must be acting downwards, okay, to have a clockwise moment. Okay, then after that, in your head, think of the perpendicular distance. So this perpendicular distance is 10 cm. This perpendicular distance is 10 cm. This perpendicular distance is 30 cm. And this perpendicular distance is 65 minus 20, which is 45 cm. And lastly, at the 95 cm mark, the perpendicular distance is 95 minus 20, which is 75 cm. So let's apply our step number 4, which is principal moment. So again, you write the two statements. Taking moments about the pivot, sum of clockwise moments equals to sum of anti-clockwise moments. So clockwise first. Clockwise, I have two of them, 20 and F. So the first one will be 20 times, what is the distance? Is 30 cm, so it's 0.3. Okay, so 20 times 0.3 meters plus, now I have this force, I don't know, so it's F times a distance of 75 cm, so it's 0.75 meter, equals to anti-clockwise. So I have anti-clockwise, I have 1, 2, 3. So I have 3 brackets over here because it's 3 different moments. So it's 20 times 0.1 plus 50 times 0.1 plus 10 times 65 minus 20, which is 45 cm, 0.45 meters. Okay, so I have a whole bunch of equation and I only have one unknown F, so I can solve for my F. My F will be 7.33 and it must be downwards to create these clockwise moments. Okay, next one, let's move on to the next example. A uniform plank of length 1 meter and mass 3 kg rests on a wheel at one end. Determine the minimum force needed by the farmer to lift the plank, which is loaded with 5 kg of apples in its middle, such that the plank will be horizontal. So if the plank is horizontal, it means that the plank is in equilibrium, is balanced. So step number one, this one is not a standard plank with the triangle pivot. You need to identify the pivot. I hope that you know that this plank will be rotating about the axis of the wheel here. So number one, the pivot is over here. Okay, this black dot over here. This will be my pivot. Okay, number two, you need to identify all the forces. I not only have this force by the farmer, I also have the force exerted by this 5 kg of apple and the plank. The plank is 1 meter. This 5 kg apple is in the center. So the weight of the plank also is downward. So I have 5 kg and 3 kg acting downwards over here. So step number two, I identify that there is one more weight caused by the apple and the plank itself. Okay, and then I identify whether it's CM or ACM. This one will cause me clockwise. This will cause me anti-clockwise. So I label it. Okay, so the first step, the weight will be 5 kg plus 3 kg, which is 8 kg, but 8 kg is a mass, it's not a weight or not a force, so I need to use W equals to mg. So I times g, which is 10, I get 80 newtons. So this W is actually equals to 80 newtons. Okay, then after that, I think of my perpendicular distance. My perpendicular distance, since it is midway, my perpendicular distance for W to the pivot will be 0.5 meters. And for this force by the farmer will be 1 meter to the pivot. So next step, step number 4, I'm going to apply my, so this is my perpendicular distance. Okay, step number 4, I'm going to apply my principal moments. So again, I write the two statements, taking moments about pivot, clockwise moments, or sum of clockwise moments equals to sum of anti-clockwise moments. So my clockwise first, clockwise will be W times 0.5 equals to anti-clockwise, which is F times 1 meter. So I'll sub in this. So my W is 80 Newton times 0.5 equals to F times 1 is F. So F is 14 Newtons. Okay, so now I have all this. These are my 4 steps to solve moments questions. You think a while about how should I rearrange them to make the steps to solve moments question. Okay, I'm going to go through now. So the first step is always, the first step, you go to here. Okay, the first step is always to identify the pivot. So I drag it to the top. After I identify the pivot, okay, I drag this down first. I need to determine the number of force and label each force with CM and ACM. Okay, number of force equals to number of moments. And then after I've determined all my force, in my head, I should mentally think of the perpendicular distance between each force and the pivot. And lastly, after I've done everything, I apply my principal moments, which is taking moments about P, the pivot P, total clockwise moments equals to total anti-clockwise moments. So remember, these are the 4 steps to solve moments question. Okay, let's take a look at this question. In this question, there is 2 pivots, P and Q. For such questions with 2 pivots, the first thing that we need to do is we need to choose only one of them as the pivot. So in this case, I'm going to choose Q as my pivot and ignore P at all. So if I were to choose Q as my pivot, I should know that FQ will not be in the calculations because FQ will have no moments as the perpendicular distance between the force to the pivot is 0. So we are going to apply the 4 steps again, taking Q as my pivot. So step number 1, I need to identify where is my pivot. So over here, my pivot will be Q. And then step number 2, I identify all the forces that's present on it. So I have FP, 600 Newton, 250 Newtons, and FQ. And then I label whether they are clockwise or anti-clockwise. So for FP, it will be turning this way, so it's clockwise. 600 Newton and 250 Newtons will be anti-clockwise. And FQ will have no moments at all. Then step number 3, I'm supposed to mentally think about the perpendicular distance between each force and pivot. So FP, the perpendicular distance is actually 3 plus 2 plus 5, 10 meters from the pivot. And then 600 Newton will be 2 plus 5, 7 meters from the pivot, and 250 will be 5 meters from the pivot. And then I'm going to apply my step number 4, which is apply my principal moments. So I'm going to write the statement again, taking moments about Q, because Q is now my pivot. Sum of clockwise moments equals sum of anti-clockwise moments. So for my clockwise moments, I only have one, which is Fp. So it'll be Fp times 10 equals to sum of anti-clockwise. Anti-clockwise, I have two of them, 600 and 250. So I have two brackets. So it's 600 times 7 plus 250 times 5. And then I solve for it, I'll get Fp equals to 545 newtons. Then how do I solve for FQ? Because the question asks for both FP and FQ. I can either repeat my steps, taking the pivot as P at P now, but it is too much of a trouble to apply this whole principal moments again. So a simpler way that I can do is I can use the sum of all the upwards force equals to the sum of all the downwards force, since this rod is in equilibrium as well. So the resultant force acting on it must be 0 as well. Okay, so sum of upwards equals to sum of downwards. So my upwards force will be Fp plus Fq, and my downwards force will be 600 plus 250. Then I sub in, Fp is 545, I'll get Fq is 305 newtons. Okay, so a summary of what we have covered so far in part 1 and part 2 of the video. We have covered that the moment of force is also known as a torque. About a pivot is the product of force and the perpendicular distance d from the pivot to the line of action of force. The formula for it is moments equals to force times perpendicular distance between the force and the line, between the line of action of force and the pivot. And we also learned that in order for an object to be in equilibrium or balance, the sum of the clockwise moments about pivot is equals to the sum of anti-clockwise moments about the same pivot. Okay, so this is what we have covered so far.